Here is my elevator circuit. On the left side, we have a bank of buttons that represent the desired floor. So the user would walk in, press one of the buttons. It would go through the priority encoder and into this flip-flop register, this enabled flip-flop. Up here, we have our current floor, and these would be updated by the elevator itself. So when the elevator passes the 5th floor, it will activate the button, which goes through a similar enabled flip-flop and stores it in the register. From there, the data values are transmitted to this comparator, and here we can see that our current floor 5 is less than our desired floor 7. In that case, we'd want to move up. So there are 3 different cases that we can consider for this elevator. The first case is if the current floor is greater than the desired floor. Second case is if the desired floor is greater than the current floor. Third case is if they're equal. This first case I've just demonstrated, which is where the current floor is less than the desired floor. Now let's see if the desired floor was less than the current floor. So I'm going to make the desired floor 3. What you see is after a little bit of a delay, the up goes to the stay and then goes to the down, which is expected in my finite state machine. Now let's say that they were both on the same floor. So we have 3 as our desired floor, so let's move our current floor to 3. You have to hold it down for a second to make sure that the timer picks up the register. So here we can see that the output is now stay. So this shows that my circuit does work. In terms of issues faced, my biggest issue was really in my understanding of the prompt. I spent a lot of time trying to figure out how to automatically update the current floor, but then I realized, looking at the schematic and talking to Pedro, that this current floor output would be automatically updated by the elevator. So that's not something that we really need to worry about.